Good afternoon, everyone. I hope you all had. I, After such an engaging morning session, from the insightful continuation of the Dr. Gnanyala's workshop to the truly inspiring guest lecture by Mrs. Janadi ma'am from IBM Quantum, I'm sure we all have re-energized and ready to dive into the next phase of today's learning journey. As we move into the post-lunch session, it's time to welcome yet another distinguished personality to the stage, a visionary whose work has significantly contributed to the advancement of India's defense and naval technology. We are deeply honored to have with us Dr. V. Bhujanga sir, former Director General of the Naval Science and Technological Laboratory, Visakhapatnam. Dr. Rao is an eminent scientist, a remarkable leader, and a driving force behind numerous innovations in defense research and maritime systems. His decades of experience and dedication have not only strengthened our nation's defense capabilities, but have also inspired countless young minds to pursue excellence in science and technology. Even today, Dr. Bhujangrao sir continues to inspire, guide, and mentor. As the chairman of the KIMS Foundation and Research Center, and as an ISRO chair professor at the National Institute of Advanced Studies, he shares his wisdom, his vision, and his unwavering belief in the power of knowledge. And today, he joins us to share his invaluable insights, an opportunity that truly bridges the world of scientific innovation with national service. A hearty welcome to you on behalf of all of us and the institution, sir. And we would like to present a small video, if you permit us to. Play the AV, please. The world of science and innovation. There are those whose vision transcends the ordinary, whose dedication shapes the extraordinary. Today, we celebrate one such luminary, Dr. V. Bhujangarao, a scientist, a leader, and an architect of India's naval technological prowess. Dr. V. Bhujangarao's journey began over 4 decades ago. In 1973, he embarked on a mission with the Defense Research and Development Organization, a mission that would span more than 42 years, leaving an indelible mark on India's defense technology landscape. As the director for the Naval Science and Technological Laboratory, NSTL in Visakhapatnam, Dr. Rao led some of the most critical projects in India's naval defense. Under his leadership, advanced underwater weapon systems, stealth technologies, and life saving naval innovations were conceived, tested, and deployed. He played a pivotal role in the development of infrared signature suppression device, an innovation now fitted on over 48 Indian Navy ships, protecting them from infrared guided missile attacks, a testament to his commitment to national security and scientific excellence. Dr. Rao's contributions earned him the prestigious National Design Award, the DRDO Agni Award, and the Stanley Early's Gold Medal. But for him, recognition was never the goal. Service, innovation, and nurturing future minds were the true rewards. Dr. Rao is not only a leader in the laboratory, but also a beacon in academia. Holding dual PhD degrees alongside honorary DSc honors from 3 universities, he has dedicated himself to nurturing knowledge, inspiring generations of engineers and scientists. A fellow of the Indian National Academy of Engineering, the Indian National Science Academy, and the Andhra Pradesh Academy of Sciences, his scholarly contributions are as vast as his practical innovations. Innovation for Dr. Rao extends beyond defense. In 2003, he founded the Condition Monitoring Society of India, a platform to promote cutting edge industrial practices, Industry 4.0, and technological foresight shaping a culture of excellence across sectors. Even today, Dr. Bhujanga Rao continues to inspire, guide, and mentor. As the chairman of the KIMS Foundation and Research Center, and as an ISRO chair professor at the National Institute of Advanced Studies, he shares his wisdom, his vision, and his unwavering belief in the power of knowledge. He is a reminder that true leadership is not in authority, but in the lives you touch, the minds you enlighten, and the legacy you leave. Dr. V. Bhujanga Rao's journey is not just a story of awards and accolades, but a story of relentless curiosity, tireless innovation, and service to the nation. A journey that continues to inspire, to challenge, and to illuminate the path for future scientists and innovators. Today, as he visits Rajiv Gandhi University of Knowledge Technology, Srikakulam, we honor not just the scientist, but the mentor, the visionary, and the guiding light, Dr. V. Bhujangara. May his story ignite the spark of curiosity and the flame of excellence in each one of us. Thank you, Dr. Rao, for a life dedicated to science, service, and the spirit of discovery. So, ladies and gentlemen, let's all put our hands together and extend a very warm and respectful welcome to Dr. V. Bhujangrao, sir. We are truly privileged to have you with us today, sir.
Can address one here.
Yes, sir.
Thank you. Thank you very much. Right. Oh, thank you. Thank you. A very good afternoon to all of you. Uh, to begin with, I must first thank your director, Professor Balaji, and it was very nice of him to invite me and given an opportunity to to interact with all of you. I have been hearing about this institution in different ways. I will explain later. And I've been looking forward to visit also. And it so happened that I had some work at GEMS, that is Great Eastern Medical School. You all know about it. It's a good medical institution in this part of this country. So I came for some work. Then he came to know somehow, I don't know how it happened. He gave a ring that time. I said, okay, I'm coming on 24th, that is tomorrow. Then suddenly it got preponed. So I came and slightly we were able to meet, but I'm very sorry we are late. We could have come much earlier, but the program at GEMS, which was not in our hands, it went out of thinking, but program went off well. So thank you very much, and my pleasure to see you all. And many young minds are here. You are all the future citizens and future experts of this country. So it's really, it is worthy. I mean, I feel worthy to be here today and interact with you. So you have seen some video clip. You might have seen some certain things like stealth technology, infrared technology, then condition monitoring, so many such things. And also, we have delivered many items in my career to the Navy for use in their services, which has been used even recent Sindur war, those kind of, though Navy did not participate as much active role like Air Force or Army, but Navy was the main backbone so that the ships cannot escape from that region or new ships cannot come to help them. So they were like a wall there. But they possessed all the weapons also. Some of the weapons developed NSTL, Visakhapatnam, for which I was the director for 7-8 years. So even those weapons were on board ready with a finger on the button when to press it. So it was such a situation. Suddenly the war was called out. It is good for the well-being of the welfare of the people. So that is how my journey started in DRDO. And I joined in 1973 at DRDL, and it was a laboratory working on missiles. Even today, DRDL at Hyderabad is the epicenter of the missile programs. around it RCI and ASL, Advanced Systems Laboratory, who develops Agni missile, all those area, that total complex. Now it is called Dr. Abdul Kalam Complex. Is there? So I started my career there. So after some years of working there, I was transferred to Visakhapatnam, NSTL. I don't know how many of you know about NSTL. NSTL stands for Naval Science and Technological Laboratory. Okay, we do work. Once it detects, we just act, switch on, switch off, or switch on only for a few minutes, or whatever it is, or switch on few lights, not off it. Suppose you take a smart car. We are now talking about smart cars, driverless cars. So what do you think? There's Iiit, triple IT. What do you think? What is a smart car should have to call it a smart? Same smart word applies there also. Anybody? Please come forward. Don't feel shy. Huh? Camera, sensor. No, sensor. What are the sensors? First you list. What are the sensors? One is camera. Radar is there. Lidar is there. Lidar or lidar. Light. What else? Any magnetic systems may be there. Accelerometer sensors are there. They're all sensors. What are the actuators? Accelerator is an actuator. Brake system is an actuator. So if these are all provided, we can convert a normal car into a smart car or a driverless car. Do you agree? So Elon Musk has done it. Who is Elon Musk? Do you know? He has made a first car into driverless car and is marketing it. Right. So now I'll ask you one simple question. There is a black cat. Black cat is there in a dark room. Very dark room. Okay. It's a very big dark room, not small dark room, as big as this auditorium. Completely dark and no air. No light ray can penetrate. So dark, and cat is black. It is not opening its eyes. Otherwise, eyes will give some clue for you, because eyes are already can be seen. Suppose you're not opening the eyes, sleeping or disturbing you, it will move. So tell me, how can you detect it? How can you detect it? What are the various systems you have to detect a black cat in a dark room? Suppose there is a submarine in water, completely submarine in deep water. It is a black cat. I have to detect it. I have to fire a weapon, okay, to destroy it. So that is one situation. Similarly, in the deep sky, there is a very small aircraft flying like Tejas, which is as good as on the radar you can see as though it is a fly, small fly size. You have to detect it and hit it. So anyone of you can say anything you got into your mind. How can you detect a black cat in a very dark room, large dark room as size as big as this? You have to go and find out. And what are the various systems you can go and I will give you anything you want in the laboratory. I will give you sonar. But when you make sonar, somehow sound, you make. So will this cat will remain there? Radar. Okay, radar is one. But what is there to give the radar cross section? What is there in the body of the cat? It doesn't give radar cross section, then you can't find out. But there must be some radar cross section. Next is IR, infrared. So these are all very good options. I'm not. You're all right. So human body, if you take a IR camera and you see it passive, you will find a IR signature. Okay, IR signature. One is there is a blood is flowing all the round in the body like as. So there is a magnetic signature because blood is made of ferrous material, iron. When iron is moving round and round 80 times per second or per minute, it goes. So magnetic field is there. So you can have a magnetometer. You go with a magnetometer, you can detect it. You can go with a radar, you can detect it. You can go with a sonar. Sonar doesn't work in air, but SODAR is there. SODAR is sound detection and ranging in air. So we can do, but we can go to high frequency, which cannot be heard by the cat, right? So which cannot be heard by the cat. If we can find such a sonar, sound producing source, then it will transmit. So reflection will come. You catch the echo. From that we can say there is something, right? What else? Cat has got electric field. Cat has got magnetic field. Cat has got infrared field. Cat has got a radar cross section. Cat has got a sonar cross section. So there are many things. So this is nothing but stealth technology. When I somewhere you have seen the word stealth, this is stealth. Stealth means secrecy. Like health, wealth, there is a stealth for scientists working in DRDO. They have to every time anything they design, they have to design that for from stealth angle. Suppose I have made Tejas, it is not enough. We have to make Tejas which cannot be detected by enemy. That means on the screen, somebody thinks normal aircraft, we can say it is aircraft is flying. But if Tejas is going, you will see even a smallest fly that is possible, that much mosquito kind you will see. So you will not detect it. So what do you make for that? How to make an aircraft stealthy? How to make a ship stealthy? Ship should not be heard, seen, visible. How to make a battle tank stealthy? Suppose we take a battle tank, put in a behind. There is a lot of trees and plants and greenery. You put there. From distance, you should not see it. That means you should give some kind of camouflage paint. Camouflage paint. From distance, you will see as though that means it is merging with the background. That is called camouflage. Camouflage is one kind of secrecy, making secret. So there's a stealth technology. So one technology is camouflage. Other one is there are paints which can absorb, radar absorbing paints are there. You make some paints, you coat that on that thing. So radar signal, when you emit, it goes slowly absorbs. It doesn't give reflection. So that is also stealth technology. Okay. Then we have sonar signals also. That means some rubber kind of material, soft material is coated on the submarine. In the front of the submarine, if you see, we have layers of soft coatings. But same time, they are very strong also. Because when you are going at speed, the flow should not carry them away. So they're very strong. They're made with a lot of embedded cavities inside. Because sound will go into a cavity and they die down. Like, anechoic chambers we heard, no? It become anechoic material. So there is one near zero, radar cross reduced to zero. Then you have infrared. So infrared means there are two kind of infrared are there. Far infrared and near infrared. Okay. So near infrared means suppose something is hot, that radiates near infrared signature. Near means in the infrared spectrum, it is in the near band 5 to 8 microns wavelength. In the far infrared is 11 to 12 microns wavelength. That is, there's no burning there, there's no hot gas, but there is hot gas is there, or plate is hot. The metal structure of the ship is hot. So that gives far infrared signature. So I must have a camera which can pick up near infrared signature and far infrared signature. Then if I take a camera, I'll get it. Now you see, you take a ship. Ship has got a main engines for propulsion purpose to take the ship forward, right? So those engines has got an exhaust, because whatever, like we have even a small petrol car or petrol engine driven motor vehicles, you get an exhaust. So for a big ship, the exhaust will be huge one, and there will be 4-5 engines, 4-5 exhausts, and each exhaust will be emitting hot gas, right? It will be emitting very hot gas. So enemy aircraft who is having infrared missiles with him, he can fire, because there is hot gas, which is like laddu for that missile. Straight away it will come, go into that exhaust system and go into the engine, and it will fire, burst. Then the engine room will get damaged, fully flooded within no time. So we have to develop some protection system. So IRSS, infrared suppression devices. So that is one such system I have developed, which was patented, and it is there on 48 ships. It is there on 48 ships. I developed by me and my team infrared suppression systems, which we have developed, so that when that system is put on the exhaust, okay, so the exhaust, when the enemy sees with this system, he doesn't feel there is a temperature is there, there's exhaust gas is coming out. That means one of the condition is there with this system and without this system. If you see the temperature, there should be a difference. They will allow a temperature difference of 1 degree compared to the surrounding temperature. If surrounding temperature is 40 degrees, with exhaust it should be 41 degrees with my system. If my system is removed, it will maybe go to 50, 60 degrees. Then easily IR missile, infrared seeking missile. That means the missile will have IR infrared sensor. So that will keep on tracking and it will see a hot spot, like a red spot, it see, and straight away lands there. So with this system, infrared suppression system, it can't land. So that is what one of the many things I have done. One of that one. That's what somewhere the discussion as a IRSS system. What I did. What I did is there is exhaust gas going inside. You put a small bigger tube, then it will also suck some gas by Bernoulli's effect from air, fresh air. So this fresh air and this exhaust air will become, this fresh air will land, we have to design such a way that the speed, everything, you control the velocity of the thing. A thin film will be standing inside all round the all around the my system, and that it gets stationary fluid film will come. Okay, that how you have to do a CFD analysis, find out such that the exhaust gas speed I know, the volume, how much I know, everything. From those calculations, from the outside temperature calculations, the day, the mid of the day, night, daytime, I know the temperatures, and you have to increase. Then that will come and stand as a film all round. So that portion of the tube will be always 1 degree higher than the ambient temperature. So the enemy cannot detect it. So when in stealth there is one principle. Suppose somebody says, "I'll make a radar. I mean, I'll make my aircraft zero zero signature body." Okay, that means that is not required. I give an example of a battle tank putting near the plants and all that, and we wanted to merge. But if I make it more contrast, then somebody will detect it. It's not just so. Same thing here also. When aircraft sees it, he should not see a black spot or a white spot. He should see a just gray spot that merging with the atmosphere. The principle of stealth is, if I am standing there, you should not. I should get merged with the background. I should not be distinct. That much only we should do. We should not make it too much. Then it will become a contrast. You can see a black something here. So that is one of the importance of stealth technology I was talking to you. So in now NSTL has a lot of good work on stealth. So we have stealth materials. We have, if radar is coming, for example, if there is a window like this, suppose a window is there. If it falls on a window, radar will give a very good signature. So what we do, we put a grid, metal grid. You have seen microwave cooker. You have seen the glass door. You have seen behind that what is there. But if there is, you will say, nice grid of the wires. It is nothing but microwave to reduce the microwaves that is coming out of that. So it is preventing microwaves to come out. Like that, same thing we do it in a ship also. Radar signal, some enemy sends a radar signal, it will go to the cavity, it will get a picture, good signal. Instead of giving that picture back, we put a grid there. So that's how so the same principle is in microwaves also. We don't want microwaves to come out, otherwise they're harmful. Microwaves are not hazardous like X-rays. X-rays are ionizing radiation, whereas microwaves are not ionizing radiation. They are good radiation. They don't harm us. But if it falls on the body, it harms. So microwave cookers, one can cook food, eat happily, because there are many doctors telling, excuse me, madam, that microwaves are bad for health. Don't cook. If somebody is having that impression, I'm telling you, and especially it is cancerous and like that. No, not at all. Microwaves are not harmful at all. Microwave cooking, when you are doing properly, should close the door. Otherwise, you may burn your hands. That's all. But they don't make the uh, food poisonous or cancerous or anything. It's a wrong spread going on. You are reading some articles from KFRC on that also. So, so some of these things I was just trying to share my experience, which I have not brought any special presentation materials with you. Okay. So, you tell me in a human body, okay, what are the sensors, what are the actuators? Can anybody simply tell what is the sensor, what are the actuators? Are there sensor, are there actuators? Yeah. Okay. If you are also having same sensors, I'm also having same sensors. Sachin Tendulkar is also having same sensor with other great game, batting they're doing, they're all having same sensors, same. Then why some people are very good in hitting the ball? Why they're not? Somebody is not. Hmm. Huh? Training. Okay, you take as amount of sun. Sachin can train his son as much he wants. But why he is not equal to Sachin then? So what is the role of brain? Yes, brain is the okay. What is the role of brain? What are the sensors? Sensors are okay, eyes. Actuators are what? Hands. Because you're actually using the and also legs sometime movement. So actuators are hands, sensors are the eyes, and for somebody when he sees a ball coming, bowling at say 110 kilometers speed, it is coming, he can track from that point to till it comes near the bat. Whereas I track, I may be tracking at some point, I may lose it because I'm not so good sensors I'm having. That is one. Otherwise, actuator side. I know it is coming very near, but I will not able to take my hands exactly there. I may be taking little this side or little this side. But so this is done by this is a something called in the brain we are doing a fusion. So we have to sometimes we use multiple sensors and we fuse them. Even in radar also, in signature no detection also, stealth also, we use multiple sensors. All sensors signatures we take, then we fuse them. That fusion is the brain part. So that may not be as good as everybody. Maybe Sachin or other, no, Rahul or those people, they have an excellent fusion inside happening. So they detect, they give signal to the actuator, that is hand, and hand takes the ball near the ball exactly. Ball is slightly going that side, it goes this side, this whatever it is, it happens. Right. So we also can become smart by training, by planning, by doing yoga, all those things, and by alertness, improve it, and maybe we can become our sensor system, our actuators is fused inside. Okay. Yeah, anybody has got any doubts, anything can raise and ask. How much time? Let's see. You have to tell me. 4:15. I can finish, no? So, so with this small introduction to defense technologies, which I gave explained to you, I gave small exposure. So I stopped my talk and I had to catch a flight at Vizag. I'm sorry I could not come early. Otherwise, we could have got more discussions, more points we could have discussed. Okay. So thank you very much. Thank you for giving this opportunity, and Madam Aruna for giving this. Thank you. Come here. I'm not. Otherwise, take a mic. Otherwise, I cannot hear you. Yeah, come near. World. Ah, right, right. So he's asking, how is it we can, what is the best way of using quantum technologies like quantum computing, quantum security, right? Rather, there are many branches of quantum. See, everywhere security is very important. In defense also is equally important. It is important to banking sector, economy, because security is very important. Similarly, for security also, for defense also, to maintain security codes inside that inside a missile, inside a torpedo, we have completely signals passing through. We should not. We have a software inside. We have so nobody can able to penetrate into that. So quantum security is very important. Present security and quantum security. What is the difference? There's a lot of difference. No, in quantum security today we can have point 4 digits 1 5. That is the accuracy with which one can give. Whereas in present normal normal right now computer bits you can't get that. In quantum security, quantum qubits you can get it. Right. That difference you must know. What is a quantum tech? What is a first of all quantum word? Okay. Quantum means in quantum physics or quantum technologies, quantum physics, there are 3 4 technologies, those 3 4 concepts are there. You must understand what is quantum. You must understand what is entanglement. You should understand what is superposition. This distinguishes from a normal thing. Okay, these are all. So in a quick bit, it is 0 and R1. It won't be 0 R1, which is a normal composition. That much I'm sure you would have taught somebody. So in this, you cannot until when you find it, the value is that much. But next fraction of a second, the value is different. That you do not know. So the prediction, that's why it's called superposition. Unless you predict one and you cannot predict other one. Entanglement also is that. So I think it's a big subject. If we get another opportunity, I'll speak to you. Right? Thank you. Thank you very much, sir. And inspired it's it's really past from one of the results and applications. The material has nothing, sensors and response. Here the data comes to be checked for the reason gathered for the response. The response is so in a million of fraction second, it has to respond, then only we will be able to meet the target or we will not be able to say we are able to see our process the target. So for this reason, sensors are equally important, response, and then comes quantum computing and how quantum computing will be integrated with the sensors and the responses. Those will be going because of that. Thank you, sir. Would you like to say one more thing? I really give us a lot of these are all different subjects. But all kind of different skills, definitely is related to the next step. It's in the past. Most of the things
So on and so forth. All these technologies, the defense research laboratories, etc., have been tremendously and terrifically using it. There's no iota of doubt on it, and we are very privileged to have Bhujanga Garu today here. And such an illustrious career unequivocally is one of the best people, and we're all fortunate. Definitely, sir. Yes, sir.